I'm now going to introduce our next speaker, which is an absolute powerhouse from Finland, Eija-Leena. She is founder of and leader of Women in AI Finland. She is running a startup. She has extensive experience in this field, so I'm very happy to announce her as a speaker today. Take it away.
Hello, all. Very happy to be here. I love this Nordic vibe that we can have in here. Let me just share my screen. Here we go. There. Okay, so I'm here today to talk about small model, large model, and data prep. And I just realized that in my title, I don't say that I'm going to talk about language models, but that's what I'm going to concentrate on. The current development of AI has narrowed the discussions towards talking just about language models when we actually want to talk about different models. And I think Suela's presentation was a great example that there is quite a lot of other things going on as well in the field rather than just language models. But I got already introduced, but yes, I recently founded a company called Renessai, and previously I've been working as a solo entrepreneur, a consultant at 2 different startups, one here in Finland called SomeBuddy, in the international brand is SomeBuddy, and also in Netherlands in the real estate industry. And one of my examples will be about SomeBuddy, or the use case will be about SomeBuddy. I'm still coaching them or acting as an AI lead and mentoring the small startup further. I also run Women in AI chapter here in Finland, and it's a great community as well as like Women in Data Science. So today I'm going to talk about a little bit about understanding different models, the role of data preparation, a little bit about the data engineering process, and then I'm going to show the case that I've been working with quite a long time. So SomeBuddy, summarizing, and then there is obviously room for questions and answers. So please feel free to type them in the chat, or then they are prepared when we have time for that one. So I want to start my presentation about kind of the definition of artificial intelligence, or what do I mean by language models. And with language models, I don't mean all of the large language models, but there's quite a lot of smaller language models as well. And those used to be called NLP or NLP techniques, so natural language processing techniques. And that is kind of a different field, and it's somewhat overlapping with machine learning. And then when we combine machine learning and deep learning, we find the little spot there that is LLMs. And obviously, with different models, you treat data differently, but then again, it's not that different. Here's another picture from which I found from ResearchGate, describing different language models. And now I don't know, you audience, how much do you know about language models? And I guess most of you have been using one of the chat versions or chat interfaces for current large language models, but there are quite many of them, smaller one, statistical one, neural language models, and loads of different techniques. I started my my natural language processing career with sentiment analysis and topic models, which are on the right hand side of the slide. And now I mainly work with the combination of smaller models and then the larger ones. As you all have have heard probably and know that the development of different larger models has been exponential in parameters, at least in the recent years. 2 years ago, we got the first ChatGPT, which kind of revolutionized how we interact with the models. And after that, the prices have gone down. There are more models, rival of different language models, and more and more parameters out there, and they are more powerful. And obviously, large language models have like positive sides and advantages, but they do have also disadvantages. If you're using something like OpenAI's GPT-4 or Google's Gemini or Anthropic's Claude, that's kind of prepackaged thingy that you can easily just, send something in, get the feedback back. But that can be costly, that can be threat to your data privacy, or if you haven't set up things right, or things like that. So there are considerations, and also you don't necessarily need a large, big model for your problem to be solved. So just as a normal data scientist does, just consider what is the most applicable model for your problem. Also, with the rise of parameters, rise of larger models, we have rise of energy consumption, and this is a topic that has been discussed in different medias lately a little bit more. But the energy consumption and water consumption for deheating and having those data centers ready and functioning for the increasing usage of large language models, well, it's not doing good for our planet, which should decrease the energy consumption. So also this is these are very important decisions one might take as a data scientist using larger or smaller models, and also how you prep the data and take advantage of the data. Another slide and a graph of kind of the exponential growth of parameters and energy consumption estimated. So it's pretty steep, and would like you to pay a little attention to this one. But so let's go to the real deal. So prepping the data for language models, and I'm talking about the real stuff here, like real life data science cases, because most of the demos or use cases that you see out there is people copy pasting things from to and from ChatGPT. Basically, that's the thing. They said that yeah, I used it, this is very effective and whatnot, but what they did actually is to open a browser, go to the app and do something there, and then just take it kind of manually copy pasting things to and from, which, as you all probably know, isn't the way things are supposed to be, and is kind of an effective way of handling data or do things in a scale. And most of the demo cases that there are for these new features, they are usually obviously like things, iris data set, but now it's just a clean desktop, or there are no missing values, no distractions, the perfect separation exists, and the real world isn't like that. The real world is that your desktop is full of screenshots like mine. You have multiple apps all the time running, and there are missing values and multiple data sources and inconsistent formats, and someone has put a space in the PDF naming and whatnot. So real life is messy, and that's why you need actually data preparation. If you had a Irish data set and you can just load it and everything is perfect, then then you wouldn't need data prep, right? And I would say that kind of the data engineering process doesn't really differ from any other traditional data scientist project when it comes to language models. You have to curate your data. You have to know what kind of data you have. Is it valid? Is it misleading? Is it outdated? Is it representative? If it's not, then what kind of conclusions can you make based of it? Then you have to probably clean it. There might be some private information, names, something that you don't want to be displayed, or there might be typos, there might be things that is gonna deviate the or put the language model, larger language model, to kind of take a wild route or whatnot. And then obviously transforming, just like we're transforming maybe in the traditional data science set things to match maybe a normal curve. So now we need to transform PDFs to text strings, or and then again to numbers if we are using smaller models. But there is quite a lot of like curate, clean, and transform going on, and it's kind of the dull and not so shiny and sparkly part of the job that is still, I would say, 70 to 80% of the time that what one needs to do. Obviously, if you understand your model's requirements and limitations, you can tailor the data to your model capabilities, so it's kind of optimal. If you understand your data, you can profile it, you know the variable distributions, you identify outliers, anomalies, for example, those spaces in the PDF file names. Then you're way better off. You can prepare for this. If you have consistent format of data, then obviously better. You don't have to come up with different kind of streams or chunking methods or whatnot. This also goes for the metadata, so that you have standardized metadata. So if you, for example, using some combined methods with larger and smaller language models, so you can filter out a smaller space of your documents. Let's say we talk about RAG, which is very popular method at the moment. Everyone wants to build a RAG application. So we might, if we have a standardized format of metadata, so we can maybe filter a smaller set of documents based on those metadata tags. And then the famous sheet in, sheet out also stands here. So if your data quality is poor, if you have outdated data, obviously it will affect your model accuracy. And documenting your issues and cleaning step will help you a long way. Also, if you take into account just the transparency and documentation and risk management requirements that is posed now by the AI Act here in Europe, so you just need to document these things. What does curating data mean? Obviously, you need high quality data sets, has lots of information. You have to balance quantity with quality. And obviously the data availability and accessibility. I come across quite a lot of projects where they want to do this kind of RAG implementation. And then when I start to ask that, where is this data? Where are you storing? What is your method of storing these documents or audio files? Or what would you have And it's like, yeah, so this person has this kind of a process and this person has this process. And I was like, okay, so you don't have a shared folder or a structure for projects or structure for anything that you would put them here. So then how would you think that a person is going to be accessing things from others' computers? So, data availability. And addressing kind of bias here as well is that if you want to, obviously this is not the case in every case. You might not need to do or you might not need to tackle the bias if you're doing research or something like that, but just understanding what is the scope of your data is very very crucial. Obviously, clean data means eliminating inaccuracies, enhancing model readability and performance. You can, as well as in kind of a traditional data science or statistics, there is imputation and removal, duplicates, outliers that you can do, and quite a lot of things that you can focus on. Sorry about that. And here's a picture of a very traditional data science, a kind of changing distribution of numbers. But if we talk about, for example, the example I'm gonna give you about SomeBuddy, there are 16 different tags, and those tags aren't represented as equal shares. So some of the tags are more common than the other ones for the data, and obviously if you want to predict something or search for something, there is a higher probability of getting those more popular tags, and then we need to think about, should we somehow maybe normalize or scale this data to represent better the whole world, or what should we do? And obviously with the text processing, with the large language models, we don't do that much of tokenization or stemming or lemmatization, which was very popular previously, but we do other things to transform, for example, from PDFs to text data. And one of the maybe like what I have encountered quite a lot recently is the role of anonymization, which is kind of which is part of the data process, data processing, data engineering, and one can use also language models to do this. But especially if you're using the larger language models that are maybe productized with the larger companies, you need to think about legal compliance, data protection risk, individual rights protection, your business protection, because you might be sending some IP, like intellectual property, like data that would give away your intellectual property. You need to think about the model output and just ethical considerations. And one of what we are actually using at SomeBuddy is just doing basic text replacement. Is there a nickname? Is there a phone number? Is there an email address? And you can have some other custom rule-based systems. And then there are for Python, for R, for many languages, there are this kind of personal identity, personal information identifying libraries, and also these Hugging Face models, like named entity recognition models that will recognize names in a certain area. So for example, in Finland, they would understand that my name, Eija-Leena, is actually is a name of a female, and maybe Renessai as a company would be a company name and stuff like that. although Renessai is such a new thing, so I don't think it's included in the dataset. But time is running, so I'll go to the case study. Somebody has digitized getting help and does it on scale. So basically, somebody has this web app where kids, mostly teenagers, can report if they have encountered something something unpleasant online. So they can ask for help. They can ask, was this okay? Was I treated badly? Is this bad? What should I do when my ex sends naked photos of me via Snapchat to his friends because of revenge or something like that? And we can go to why is this important? Why is this a product that is not out there widely? But I will focus on the data engineering part today. What happens next? So when a younger person, or it could be an adult as well, teacher or anyone, has sent a report, anonymized report, it will be diagnosed with the help of some models, and then the lawyer and the psychologist will go through the case, will assess it. Was this crime maybe? What should one do? What are the kind of risk mitigation steps to take? And then they will send via this same web app kind of this survival kit that we have named it, and the person will receive the full assessment of the report and mental health support and like very concrete steps how to, for example, remove content or something like that. The high level data flow is that there is the app, and actually it's an app for the end user and app for the case handling, but let's just talk about app. Via the app, the data is saved to a database that serves these apps. Then obviously, even though the whole data collecting process is anonymized, there are open fields so people can mistakenly or against the instructions write names or whatnot there. So we need some anonymization process for further to save the model for to be used in the models. Then there are some transformations and obviously some other cleaning to be done there. Then these are saved to an analytics database, and then we can use that to train some models, do search, and show the data on a dashboard. And well, pretty easy, yes. Well, it has taken quite a long to think about it because basically, what do we have? So we have a app who ask you questions. What have you encountered something bad online? Yes. Have you suffered some maybe that you didn't go to school or something like that? And the questionnaire is designed so that only the necessary questions are asked, nothing else. And it's a little bit different for the cases where maybe someone has called you with bad names on Instagram, than maybe stolen your identity in a game, or then maybe spread your naked pictures in Snapchat. So it's a little bit different things that things that is interesting to make the kind of the legal assessment. So we get the data as question answer pairs. Obviously, we need to put it on the database. And then we need to make sure that we have kind of a similar level data in a similar places. So we can maybe train a model, we can search from that database. So we have questions that we asked from a case that where there was a picture spread that is kind of matched to the case where maybe your identity was stolen. So there is this kind of a matching logic going on. Then obviously we need to have an API or some service to, for example, have embeddings for those. So we can do a search. So we have something in the cloud running, like a named entity recognition. Was it probably some transformers bird-based Finnish trained model directly from Hugging Face. And then obviously there is, because the lawyers and psychologists don't know necessarily how to use the Python code, for example, they have this button in their UI to tackle or to search for the similar cases. I'm going to skip this because I see Lena appearing on the screen. And then I'll just summarize my talk that everyone at this point in time wants to do this, like how many, 1, 2, 3, 4, 5 steps at the same time. Forget about data, forget about statistics, forget about machine learning and evaluation, and just jump on the GPT train, which is not the most efficient and will not work in production. But I guess now it's time for questions and answers.
Yes. Amen. That was very interesting. So yes, let's jump into Q&A. We have a question from Deborah. How do you define fair to ensure data fairness?
Fair, probably that's a very broad word, but I guess it really depends on the context. For example, in the case of SomeBuddy, fair would be that we are using the models and we are using the data to enhance the capabilities of a lawyer and a psychology. So fair would be to have enough information, and if we don't have enough information, for example, of certain cases, we would inform those people. And obviously we cannot make up with the data. So in this case, kind of you just need to be aware of what you have and what you don't have.
Yes. Another question from Anuka. Are you using any bias detection or mitigation methods that you would recommend?
Bias detection as in well, in this particular case, we already know that there is bias because we don't know the phenomenon, like this social media bullying and harassment phenomenon. We don't know how it's evolving and how it's we know only the tip of the iceberg, basically, because we have cases of only those cases that we actually got the youngster to send us message and ask for help. But other than that, in this case, bias detection, no, not really. We don't do that. And I haven't encountered anything that would be, let's fix all kind of a thing.
All right. Next question. Thank you for the talk. I have a question. How do you balance the need for privacy with maintaining data quality?
Yes, that is a very good question. What we have tried to do, first of all, like designing the questionnaire and designing how to gather the data. So trying to minimize kind of the data that we gather. So just actually what we are interested in and what on based on what we are actually doing decisions. So we're gathering that. And yeah, sometimes it results in poor quality of data, and we cannot really via this kind of app go and ask again, like, or obviously we can send a message that, hey, could you maybe tell a little bit more about this and this part? But as you know, kids aren't necessarily very good at that. But it's a fine balancing all the time. And then obviously, if we want to keep the data and use it for training, we need to anonymize it. But then if you, for example, anonymize all the let's say that there would be quite a lot of names and nicknames and, let's say, companies, and then you would replace everything, for example, with the named entity recognition model with company name, person name, and then you would do those embeddings and use embedding similarity to search something. So you would guess that every time there's a person, so it would actually make the cases closer to each other, which are anonymized. And that's actually not necessarily the correct way of making things closer to each other.
Yeah. Yeah, really interesting. Interesting question.
Yeah,
And
that's it. Balancing, yeah.
yes, yes. Thank you so much. I really loved your point there that you need to pay attention to the data processing step. There's a lot of attention given to the models and the coolness of it, but there's a lot before. Yeah.
It is lots before, and it doesn't really go away with all these large language models. Like, you can skip it, but the results won't be as good as you wished for, and it might cost you quite a lot of money.
Thank you so much, Eija-Leena.